Right? Okay. Speaking of homework, I'm going to start figuring those grades and doing that substitution too for your lowest test. So hopefully that will help most of you. Before I erase this, let's go over it right now. All right? So here we go. You're going to use the formula. So the first thing written on your paper should be x equals 12 over 6. So x equals 2 is your axis of symmetry, which means your vertex has a 2. Now, where do I go from here? I plug it in, so in it goes. 3 times 4 minus 12 times 2 plus 6. 12 minus 24 plus 6. Let's see, that adds up to hopefully negative 6. Does that look familiar? Up or down? Up. Good. How many perfect papers so far? Okay, if your hand's out up in the air, do you see what you did wrong? Do you have a question about it? Because we're moving on. There's a lot of stuff in this section, this chapter. Okay, now we're going to write the equation. Y equals nx plus 2 squared minus 3 that's just step 1. That's just how you start. This tells me I have moved 2 units left and 3 units down. Right? Okay, so now I'll plug in my 6 here and my 1 here. So what's that? 9n. Oh, this works out nicely, doesn't it? You probably think I planned that. I didn't, but it sure is nice. So y equals x plus 2 squared minus 3. You can put a 1 out there if you want, but you don't have to. Joseph, you doing all right?
Yeah.
Okay. All right, we okay with that then? All right, let's take a look at our note sheets. We're moving on to section 2.2 now. Come on, get them out. Let's go. We're going to write the equation for the following. There are 2 kinds of variation that you are going to be responsible for. There is what's called direct variation, and then there is inverse variation. Question number 1 is going to give us the general formula we're going to use when things vary directly. Now, let me give you an example of things that vary directly. Okay? Let's suppose Quincy and I both go to the store to buy bananas. Bananas are 50 cents a pound. Quincy buys 2 pounds of bananas and I buy 3 pounds of bananas. I buy more bananas. Who's going to pay more? Why am I paying more? Because I bought more. That's direct variation. Direct variation is if you buy more, you pay more. That's direct variation. Now let me give you an example of inverse variation. Let's suppose Ethan and I live in the same house. We do not. But let's suppose we did. And we both left for school in separate cars at exactly the same time, and we drove exactly the same route to school. I drove 40 miles an hour. Ethan drove 50 miles an hour. Who gets to school first? Ethan does. So wait a minute. More speed, a higher speed, meant less time? That's inverse variation. When one quantity goes up and the other one goes down, go faster, more speed, less time. That's inverse variation. Direct variation is when they both go up at the same time or down at the same time. Okay? All right. So, A says, what is the formula if y varies directly as x? Very simply, direct variation is y equals kx. That's the answer to question A. Anytime they vary directly, it's y equals kx. So I'm going to skip down to C, problem C. I'm going to do all the direct ones in this column. So I'm skipping down to C for a moment. Key varies directly as the square of Q. P equals KQ squared. Varying directly means you have this format. One variable equals K times the other variable. In problem C, your variables are P and Q squared. P equals KQ squared. E, another direct variation. Height varies directly as weight. Height varies directly as weight. H equals KW. What that means is, generally speaking, the taller you are, the more you weigh. And I know that's not true for everyone. I mean, I know it's not, but in general, the taller you are, the more you weigh. Those are direct variations. Notice how you have one variable equals K times the other variable. Now, inverse variation, that's the one like more speed, less time, one gets bigger, one gets smaller. This is question B. That formula is y equals K over X. So when things vary inversely, that's your setup. If they vary directly, this is your setup. So look at D. M varies inversely, so M varies inversely as the sum of A and B. There it is. Yes?
Can it always be on top?
When you do inverse variation, yes. When you do direct variation, it's out in front. So M varies inversely. That tells me I have this setup. K over the other thing, which is the sum of A and B. Now, F is tricky. F actually goes in this column. The words is proportional to means direct variation. So Y varies directly as X is proportional to X. The answer to F is exactly the same as the answer to A. It's two different ways of wording it. When you see is proportional to, that means varies directly. You buy more bananas, you pay more money. You make more cookies, you use more flour. Is proportional to. All right, let's try a word problem now. These I'm going to ask you to do in 3 steps. And that'll be easy for you to remember because each sentence is a step. Oh, I forgot G. Sorry, G goes here. G is inversely. Rate is inversely proportional, so it's going to be R equals K over distance. There we go. R equals K over distance. Sorry about that. All right, now on to part 2A. 3 steps, okay? Each sentence has a step. So sentence 1, I want you to write the equation just like we did here. So anybody want to take a guess at it? Temperature is directly proportional to volume. Temperature is directly proportional to volume. Robbie?
Is it T equals KV?
It is. T equals KV. Why did he do KV and not K over V? Because it says directly. And directly means K times. Now, step 2 is the second sentence. It says the temperature is 70 and the volume is 30. Do you see what I did? I took the equation that I wrote in step 1 and I plugged in the temperature and the volume that they gave me. Now, what am I going to be able to figure out? K is 7/3, 70 over 30, 7/3. So now my equation know what K is, my equation can be written T equals 7/3 times V. Now look at the third sentence. Find the temperature if the volume is 20. What am I going to do? Put 20 in for V. So T equals 7/3 times 20. Now remember, when you multiply 7/3 times 20 over 1, it's top times top and bottom times bottom. So that's 140 over 3 degrees. And if you want a decimal for that, you can get a decimal for it. And then we're done. So let's review those steps again. Remember, every step is a sentence. So sentence 1 gave me the general setup, right? It says directly proportional. What happened in sentence 2? They gave me a T and a V, so I plugged those in and figured out K. And then in step 3, I already know K. They gave me a V, so I figured out the T. Is that easy enough? Seems to be. Let's look at B, problem B. Volume varies inversely as pressure. Okay, now remember what that means is you're gonna have this kind of setup. That's your inverse setup. So anybody want to take a guess what that first big equation is going to be for V, the first sentence? What's it going to say? V equals K over P. Now I can't tell. Are you getting that? Is that okay? All right, now let's look at the second sentence. What does it do for me? The volume is 200. The pressure is 40. Does that look okay to everybody? So multiplying both sides by 40, K equals 8,000, which means my equation is V equals 8,000 over P. Go back to this one. Now I know what K is, though. I can plug in my 8,000. And then I can answer the third question. Find the pressure if the volume is 950. Find the pressure if the volume is 950. Does that seem like an okay setup? It says find the pressure if the volume is 950. Okay, how do we solve that? That's a little harder to solve. What are we going to do? Come on, first year algebra, you can do it. Multiply by P, so we have 950P equals 8,000.
Divide by 950.
And divide by 950, so we have 8,000 over 950, which I'm sure reduces to something. Well, if you do it as a fraction, it's 160 over 19. If you do it as a decimal, it's about 8.42.
Which one?
Doesn't matter to me. Well, fraction would be better, but I'm not going to count it wrong if you use a decimal. The fraction is better because there's no round off error in it. All right, that's section 2. That's 2.2, done. That's all there is in 2.2 that you need to know. So now you can do your 2.2 assigned problems. They're like these. Okay?
So we should memorize these equations.
Well, you have to know the format, the two formats. Remember that direct is y equals kx, and inverse is y equals k over x. Yeah. There's only two. And remember, one is k times, and one is k divided by. I don't know how you remember. I still straight. Oh my golly, look at this next page. What in the world? Let's talk about this. Because, boys and girls,
It's just like.
We are going to sketch all these without our calculator. And you're thinking, whoa, I'm not smart enough to do that. And you know what? You're double smart. You're way too, you can do this. This is going to be easy for you. Okay? Here's what I want you to do first. I want you to put 3 dots on the x-axis. I want you to put a dot at -1 and label it just like Mrs. Ford did. I want you to put a dot at +2 and label it, and another dot at +3. Okay? Now I'm going to give you one more piece of information, and Ethan's going to get mad because you have to remember this too. But how a polynomial function behaves, and that's what this is. If you multiplied it all out, it would be x cubed, right? It's a polynomial. And how x cubes behave, remember your BFF, this is how they behave, right? They start down and end up. Now, when we start putting more stuff into the problem, not just plain x cubed, but more stuff, it gets a little squiggly in there, and you're going to figure that out. But it still will start down and end up. So this curve is going to start down here and end up here. So what did I do? First of all, I had to remember x cubed starts down, ends up. So I started my picture down here. All of these dots that you plotted have to be connected. So I started, okay, and then I had to come up and turn around because I have to connect to this dot. Now how high you go, I don't care. That's a calculus problem. I'm not worried about that right now. I'm just going to get those 2 dots connected. So then what did I have to do? I had to turn back around to connect to that dot, right? And then I just sail up into space. Because what do cubes do? They start down here and they end up here. Now, does everybody kind of see where I got these dots to start with? These are called the X-Intercepts, or the zeros of the function, and they came straight from the factors. Can everyone see that? Now, without my guidance, without me saying a word, can you do B? Problem B. Can you sketch in B? I will do it up here, but I'm not going to say anything. See if you can sketch in B. How's that look? Does that look like, yours is probably nicer looking than that, but did you have something that looks along those lines? Were you dots in the same place mine are? Started down here, ended up there? You got it. Now, there's something different about problem C. First of all, problem C only has 2 dots. One at -1 and one at 3. Would you agree with that, looking at the problem? I'm on problem C.
Doesn't the square mean there's 2 x plus 1?
Well, there's 2 x plus 1s, but I can only plot it in one place. I mean, the dot would be in the same place, so it looks like they're I mean, I could try to put another dot on top of that, but it's still just the same dot. Okay, now, Quincy says, there's got to be some kind of graphical implication, and he's right. He said that term, that x plus 1 squared, is quadratic. Just that term. Now, wait a minute. How do quadratics look when you graph them? X squareds, what do they look like? They're parabolas. So what happens, Morgan, is this. The curve still starts down here, but when it hits that point, because that factor was squared, when it hits that point, instead of going through, it bounces off. It makes a little parabola-like shape there. Now, why does it do that? Because its factor was squared. Now, remember, you still have to connect to that dot, so at some point it's going to turn around, right? And again, I don't care how far down you go, you get to pick. Go down and come up. When you come up, am I going to bounce off again here?
No.
No, because the only time I bounce off is when I have that. So I'm not bouncing off, I'm heading up into space. Now, all three of these are x cubed. If you FOIL them all out, you get x cubed. They all have the same general shape, right? That's what x cubes look like. Now I say that because look at D. Tell me what's different about D. If you FOILed it all out, it would be x to the fourth, wouldn't it? D? Problem D, wouldn't it be x to the fourth if I FOILed it all out? Alright, so I need you to remember something. X cubes start down and end up. Okay? And actually that's true of any odd power. So if we were doing an x to the fifth or an x to the seventh, any odd power is going to start down and end up. Tell me about even powers. Think of your parabolas, x squareds. How do they behave, Paul?
They end up similar.
Exactly. They start up and end up. So if you have an even power, you start up and end up, just like a parabola, starts up and ends up. So if I'm graphing problem D, I only have two intercepts, +2 and -3. And yes, as Marley pointed out, I actually have 4, but they're the same, so it looks like just 2 when I graph them. This thing starts up and ends up. That's what fourth degrees do. They start up and end up. So I'm going to start up here. Now what am I going to do when I hit this point? I'm bouncing off of it, and I'm bouncing off of it because of that squared right there. So at some point I got to turn around and come back down because everything is connected. You have to connect your dots. What am I going to do when I hit this one? I'm going to bounce right back up again. And sure enough, I started up and ended up. This is not hard, but you do have to remember a couple things. Oh my, look at E. Okay, let's start by getting our dots plotted, and then I'm going to ask you a question about it. So let's get everything plotted. Please notice how Mrs. Ford is labeling her points. That is my expectation of you.
Do we take off points if we don't?
Yep, you know I will. What power would this problem be if you multiplied it all out, which you're never going to do? I'm not going to have you ever do that, but if you were, it would be x to the fifth. Now 5 is odd. So how do odds behave? Start down, end up. So I'm going to start down here. Now I have to look at my problem to figure out what I do when I get to these various points. Things are not necessarily in order, kids. This dot right here came from this factor. So what am I going to do when I hit it?
I'll keep going straight.
This one just goes straight on through, doesn't it? And it goes up a ways and it comes down to here. Okay? Now what does it do when it hits there?
Bounce back up.
That one came from this, right? -1 came from that. And it's squared, so it's going to bounce off.
Yep.
And remember, everything's connected, so it comes back down.
Bounce back
What
up.
does it do when it hits there? It bounces back up. And there is a picture. Hey, you guys, you should be impressed as heck. Look at that equation, and you just graphed it without a calculator. So at dinner tonight, when Mom and Dad say, hey, what'd you learn in school today? Whip out your napkin and show them this. They'll be really impressed. Looks really hard, but it's easy. Take a look at F. Okay, there's something a little bit different about F. What's different about it? There's a cube. Okay, now wait a second. We talked about how to deal with factors when they are squared. How do we deal with them when they're squared? They bounce, right? How do we deal with them when they're cubed?
Would you start by drawing through the cube one first? Like start it down and then go up?
Oh, that's a good idea. But actually, no. The position, relative position of the cubed factor to the other zeros will determine which way it goes. But, Robbie, part of what you said is right. You're going to go through an x cubed 0 the same way you graph this guy. Now, when you graph him, you don't do it like this, do you? You don't go straight through it. What do you do with this? You kind of, I call it meander through, right? And that's how you're going to go through an x cubed, okay? Now, whether I'm coming from the top or the bottom is going to depend on how things are connecting. But that's the way I'm going to go through it. If I'm going the other direction, I'll go through it like this. I kind of just wiggle my way through. All right, so what's the degree here? If I multiplied it all out, what would the power be? It'd be even. X to the 4th, but it would be even. Evens are start up, end up. So I'm going to start up here. Here I come. All right. What do I do when I hit that guy? Now be careful. He came from this factor, guys. Pay attention to the factor he came from. I just go right through, don't I? Like a line. It just goes through. But now I got to turn around, right? And when I come back up through this one, that's how I'm going to wiggle through. So I'm going to kind of plan ahead here and wiggle my way through. You told me it would start up, end up? And it does. Uh-oh. Uh-oh. G has another complication. Hang with me. We'll take a little break here in a minute. Do something fun. I mean, not that we're not already doing something fun, but we'll do something maybe a little more fun. Gotta get through a couple more. All right, here we are. Let's put the dots on there first. Now notice that my dots, my X-intercepts, are only coming from the factors. So I see that -2, but I'm not graphing that -2. I'm only graphing my X's. So I've got one at -1, one at 3, and one at -2. Now think back to when we were graphing those y equals f of x weird shapes, remember? What happened when I put a negative out in front of that? What did it do? Upside down. Okay, now wait a minute, upside down. If I FOILed all this out, what power would it be? X to the what? Fourth? X to the fourth? Now, x to the fourth should start up, end up. But we're turning it upside down because of the negative, so it's going to start down and end down. So it's going to start down here. Now, don't worry about the 2. We're not plotting any other points. All you have to worry about is the negative. Okay? You don't need to worry about the 2. If we were plotting points, we'd have to take that into account. But we're just sketching. What you do have to pay attention to is the negative, though, because that turns it upside down. So here I go. I'm coming in from the bottom. That dot came from this factor. It's not squared or anything, so it's just like a line. It just goes straight through. And then it's got to turn around and hit this one. What's it going to do when it hits that one? Go straight through, just like a line. Then it's going to come up and hit that one. And that one is going to bounce off. So remember when you told me it would start down and down?
Yeah.
That's what happened.
So we don't have to worry about the number just out
Nope. Nope. If we were plotting points, you would, what that does, Chris, just like before, it's gonna make it twice as tall. But since I don't even know how tall that is to start with, I'm not gonna worry about it.
Okay.
But if I was physically plotting points, I would multiply by 2 and get it. So if it came out, you know, if I stuck in the number 5 and got 12, I would plot it at 24 instead, because it's 2 times. All right, H, here we go. Last one. And I'll let you get up and move around and do something fun. Oh my gosh, this thing's a monster. Okay, so here we are. Here we go. So I've got 0 at -2, at 1, and at 3. Lousy. Okay. All right. Now, before we can start, we've got to figure out what the degree is, because the degree is what's going to determine how we move, you know, where we start, where we stop. So by degree, I mean if you multiplied it out, what's the biggest, or what is the power that you would have on your x? X to the 6th. Okay, now wait a minute. X to the 6th. That's even. How do evens behave? Start up, end up. It's got a negative in front of it, so this one's going to start down. So it's going to start down here. That gets me started. Now I know where I start. I start down. Uh-oh, uh-oh. That guy was a cube. So I'm going to come back and redo this a little bit, because I have to kind of wiggle my way through him, right? Wiggle through. Now it's going to come up a ways. We don't know how far, and come back down.
I have a question.
Yep.
Are we going to quiz over this before the first quarter?
Yep.
Good.
We're going to have a quiz over this the next time we're together. Which,
Just this.
well, and one more.
Friday.
That's crazy.
Friday. All right, now what happens when I hit this guy?
Goes through.
Goes through. And it goes through, boys and girls, because that point came from this factor, which isn't squared or anything. So it comes down a ways, and it comes back up. And when it gets there, that's a squared, and we know squares bounce off.
Yes.
Whew. So there is a picture of that function.
Break time?
Okay? No, it's not break time. Now what we're going to do, well, not really, but sort of. What?
Until I was about to ask the same thing. That's why I said break time. I thought that's what this was.
Okay. Last time we had a break, though, a bunch of you ended up here because you were gone too long. So I'm gonna give you exactly 3 minutes to get to the bathroom and get back here. So everybody's back by the time you get out here. 1:53. We're starting in, if you're not in your seat at 1:53, you'll be bringing Kleenex.
I don't know if I can be able to see that.
Just go.
No, you're wasting time.
Yeah, you're sitting here wasting time.
What were you gonna have us do?
Well, I was gonna have you move to a different seat. We'll do it when they get back. Right now, you can just relax.
This is good. I won't be here on Friday, so should I take the quiz tomorrow?
You can.
Okay. When should I?
Why don't you come before school?
Before school?
That would be good.
Are we gonna learn the next piece today?
Huh?
We're gonna learn the next piece
Yep,
today.
but it's easy. The next piece is easy.
Yeah, today I thought the quiz was just the axis symmetry formula.
No, I told you I had 2 problems on it.
I must have mistaken you, because I got those right.
Can I come before school on Friday and take the 1.7 quiz? I
No.
think I have to take that.
Okay, once we take the test, you can't make up the quizzes. It's too late.
So can I make it up before school tomorrow?
Honey, we've already taken that test.
We have?
1.7, yeah.
Yeah, we have.
And on the quiz, will there be like the bottom ones or like what strength or difficulty?
It'll be like any of
say
those.
these are
They're all the
easy,
same.
These are medium, these are hard. I'm just trying to be prepared.
We've been on
Ball trip was my favorite one, and I totally loved it. And I told them my later, of course, it was right after that, I got diagnosed with cancer. In fact, one trip, my, Sunday mornings, my hands were just like, yeah. Yep, but I'm ready to go.
Mrs. Mills told us our nappy teacher that because like your hair is spread back, it's like softer, a lot softer than.
Oh, every time I'm with Mrs. Mills,
Yeah,
she like scratches
she
people
told
and
me she
says, pet her, pet her, pet her, pet her. People, random people are coming up and petting me. Yeah, it,
I'm sure that's what.
and it knows it's because you were when it was first coming in, it was really like, you know, because it was like whispers.
That was some extra effort.
Now it's-
Ah, see?
But it's starting to get long enough that it's doing some.
Stop.
I always had really straight hair, but some of it's kind of sticking out. I'm not sure what it's doing, but.
Shut up.
Ethan, why don't you guys sleep at night? Nick, why don't you guys sleep at night?
We do.
It's been a long day.
It's just not
We still
enough
have another
sleep.
period to go.
Oh,
Do we really?
That one's
actually I actually forgot about that. I really thought this was the last
I
period.
thought it was the last period of the day, man.
So childish.
That is nice.
The bad news is we don't have this class tomorrow.
I know.
That is bad. For me, it's bad. I wish I could see you every day.
I'm ready.
Okay, here we go. 153 in our seats. All right, what I want you to do is take a old quiz or a scrap piece of paper, you know, a sheet of paper, maybe use a brand new sheet of paper, and I want you to move to somebody else that you don't work with all the time. So like I don't want you two working together. I want you to get up and move. I want you to write a problem like this. Write one of these problems and give it to your partner to do. You're gonna swap problems. Okay?
That was actually such a good one.
What are we doing? Oh, okay.
Swap
Hey, Polly.
Okay, so we are going to Write a problem like the ones we've been doing, that page of problems we've been doing. Write a problem. Come on, write your own problem and then trade it. You're gonna trade your problem. And then you're gonna check each other's work. You're gonna make up your own, kind of like that. You're gonna make up one, she's gonna make up one. You're gonna trade each other's work.
Wait, are we solving each other's problems?
Yes, we're solving each other's. Graphing. So we are graphing each other's problems. Making them up about problems. However you want to do it.
Yes, sir.
Remember, Paul's got to be able to do it. No, he's graphing yours, you're graphing yours. Honey, just like I've been doing, just set up some parentheses and put some powers on it. Yeah. Yeah. So you can make it hard, but remember, your partner has to solve it.
You already saw that?
Yep.
What if we have an odd number of x's, but it's negative?
So it's up, ends down, that's right.
Yes.
Alright, I need the first, I need, if you are done, if you have drafters, I need you to take it out, put it on the board. Write the equation in the picture. We're not gonna have room for everybody's, we're gonna check some of them.
Balance.
Write the equation in the picture, you can use this board over there
Nick,
too.
can you toss me a marker?
Can I erase the bonus?
Yeah. You can erase everything.
Justin, do you still like that? Okay, so we're writing down the equation and we're drawing the picture. No.
So it would start on this square on because I thought it was negative.
Alright. Yeah, those of you that didn't get a chance to put it one on the board, let's look at what's up here. Yeah, you can put one.
Emily, will you bring a marker back here, please? When you come back.
Somebody took it, I don't know where they moved it.
All natural? Oh, that's frightening. Does it taste good?
They're amazing. Pumpkin seeds are so much better than some flower seeds, and you don't have to worry about the rotten fruit in your tongue.
I'll believe it when I taste it.
Taste it.
You just eat them like that?
No, you just eat it like this.
I just literally chew it out.
Yeah, you just chew it water.
Are they good for you?
Oh, yeah.
Okay.
Are they good?
All right, let's pay attention here. Next time we're together, we'll have a quiz over this. And we may or may not do a practice problem. We're practicing a whole bunch right now, so you need to remember. All right. You look at this problem, what goes through your head? What power? 4. That means start up, end up? Whoops.
I was starting out. There was nothing.
We could make it, right, by putting a negative in front of it.
Sorry.
Now it would be right. Would you agree with me? But if it had been like it was in the beginning, it would have a W shape, not an M shape. Because this starts up, ends up, unless it has a negative, and then it starts down, ends down. Nick, got it? All right, this one, beautifully done. It's a cube, starts down, ends up. No bouncing, no squiggling, just woo, there we go. What's the power here? That's a biggie. That's a big problem. Notice, okay, wait, 6, start up, end up. Notice we started up here, bounced off, squiggled through, and went straight through. That problem matches everything.
Sorry, I forgot to put something on here.
Oh, okay.
I brought that in.
All right, everybody okay? That's a tough
So I
one.
shouldn't
That's
come
a
in
tough
yet?
one. All right, over here.
You got this, Robin.
Everybody okay with this one on the top? Now, I can't emphasize enough that you've got to remember the rules. Odd power, x cubed, x to the 5th, x to the 7th, means start down, end up. This one has a negative in front of it, so it's starting up and ending down. Look at this now. That's a 4th power. Hey, guys, I know the pictures back there are absolutely fascinating, but this is where the action is right now, okay? Maybe someday your picture will be on the wall. Pay attention in class, yeah. Okay, so now we're going to x to the 4th. Okay, start up, end up, but it has a negative, so start down, end down. We bounced at -4. We went through at -3 and through at 2. Good work. Good work. Uh-oh, something's wrong here. What's our power? 4. Whoops. 4s can't start down and end up. So let's see. Something's wrong. What is it? Can we figure out what's wrong? First of all, we have to start up. Who did this and didn't label your points?
Ah, shoot.
Very bad. I'll label our points. All right, what do I do when I hit -3? I go through. Oh, here it is. We bounce it that way, don't we? Don't we bounce it 1?
Oh my god.
And how about this one? Oh, here's another one.
I didn't label my points.
Yep, points aren't labeled, but it looks okay shape-wise. How about over here? Oh, there's an upside down. What power is that?
The 3rd.
6.
No, that one's 2.
So did we squiggle through, bounce off, and go straight through? Good. Stop it, Ethan. Okay, now, let's look at this blue one right here, guys. Excuse me.
Sorry.
We have an issue. See that point right there? I don't think we're supposed to be crossing that. What's wrong with this guy? We're supposed to bounce right here and then come back up. You cannot cross the axis unless it's one of these points. You'll just be making up other points to cross. That's a squiggle, that's perfect. All right, think you got that part down? Everybody know? All right, look at the next page of your notes. Now we're gonna do it backwards. So now we're gonna do it backwards. We got 10 minutes. Get back in your seats, get back to your notes. We have 10 minutes to figure out how to do this backwards. Alrighty, so I'm looking at problem number 1. You need to be able to give me 3 parentheses for problem number 1.
Wait.
Why are there 3 parentheses? What's problem A? I'm on 2A now. There are that many points on the x-axis, and remember, look around you. However many parentheses there were, that's how many dots you had, right? So what are my parentheses going to be?
X plus 2.
X plus 2.
X minus 1.
X minus 1. X minus 3. Step 1 done. Everybody good? That's easy. Now, do any of those parentheses have powers on them? Let's see. The minus 1 has a square. How does Ethan know from looking at the picture that the x minus 1 has a square? Because the picture bounces off at that point. Okay? Now, here comes the tricky part, but you're used to it because you did it with your parabolas. There's a coefficient out here. I don't know what it is, but I'm going to figure it out. Anybody have any idea how I'll figure out that coefficient? Look what you were given in the problem. Do you see a random point in there? Plug in that point. You're told that if x is 0, y will be 2. That point's on the graph. So I'll put 2 in here, and I'll put 0 in for all of the x's. This is what you did with your parabola. Remember, you had to figure, you put in your vertex, and then you had to figure that point. So 2 equals n times, all right, this is, whoops, that's a square. This is a 2. What's this? Remember, that one's squared, so that'll be a 1 and a negative 3. So multiplying all that together gives me negative 6. So n equals negative 2, 6, which is the same as negative 1/3. That's your n. So now you can write your answer. Y equals negative 1/3, x plus 2, x minus 1 squared, x minus 3. That's your answer.
How you got from 2 equals n, negative 6?
Divided both sides by negative 6. This is negative 6n. N times negative 6. To solve that, you divide both sides by negative 6. To get n by itself.
Yeah,
So negative 2 over 6 reduces to negative 1/3. All right, let's try the next one. First thing you're going to do is set up some factors. How many factors will I have this time?
3.
3. And what will those factors be?
X plus 4.
X plus 4.
X plus 2.
X plus 2.
X minus 3.
X minus 3.
Are you done?
Do I have any bouncers? Anything bouncing off anywhere?
One of them.
No.
I don't think anything's bouncing anywhere. So I'm ready to go. All I need to do is figure out my N. And how am I going to figure out my N? I'm going to plug in a point. What point am I going to plug in? 0, -3. It's right there in the graph. It's a point given on the graph, the only one that's not a factor. So -3 pulls in 0 plus 4, 0 plus 2, 0 minus 3. So that's 4 and 2 and -3. What does all that multiply to give me? -24. So dividing would be 3 over 24, 1/8. Yep. We may practice one of these before we take it. If you don't make me mad. And here's your answer. Okay, we're gonna do one more. One more, we're gonna do C.
Oh my gosh. We do it on our own then.
Yep, you can do it on your own. I'll do it up here, you do it there, that'll be perfect. We're all working on letter C. Oh, it's got a bit of a trickiness in it.
You added 2 to do
Oh no, the 2-2, that we're gonna plug that in. The 2-2 is not an issue yet. Did you catch that you got a dot at the origin?
Mm-hmm.
So you can either write x minus 0, x plus 0, or just plain x. It's up to you, whatever you're most comfortable with. But you have it at 0, so you have to have an x in there. Either x minus 0, x plus 0, or plain x. And by the way, that one will be squared.
No way I can do
What? Okay, let's talk about it real quick. Did you have a squared on your x plus 2? Did you have a squared on your x minus 0 or x plus 0 or x? And nothing on the x minus 3. So I put 2 in for all of the x's and the y, because the point's 2, 2. So 2 plus 2 squared was 16. 2 squared was 4, and that made a -1. So I got -1 over 32. Did you?
Yeah.
So this is what you ultimately write in the answer blank. Now, let's remember, we got homework we're supposed to be doing. We should have 2-1 to 2-2 finished, right? I don't know when it's going to be due, depends on when we're ready for the test. It will not be before, I mean, it'll be after fall break.